All right, so again, we're going to break down these radicals. The key are these numbers in red. Now, you've had them in everything we've done the first 2 days on these. So they've been on the note sheet. We put them on the note sheet yesterday, too. And the key to these is they're going to be perfect and let us actually break them down, where the radical's not going to be there anymore. So here's kind of our game plan of sorts. 32, for instance. Now, here's the key. The key whenever we're breaking these down is one of these will divide into here. And if I'm not sure of which one, I can always let the calculator try to help me out.
16.
It is. And I want the biggest one. And Eric, good. That's 16. So if I divide 16 into 32, it goes in twice. And again, just using the calculator and playing with these is all we got to do if we're not sure. But here's the key to all of this. They're both still square roots, okay? But the square root of 16, if I've got my list, I see it right here. It's 4. So that's 4, but the 2 isn't anywhere in my red radicals, so it's got to stay in radical jail. It is not perfect. It does not get set free. And that's all I'm doing, okay? So even if you're not an expert with your multiplication skills, with the calculator's help, you can make this work. So what happens, though, when I start throwing in funky things like variables? Still going to do it just a piece at a time. When I do the 27, I find out 9's the largest one of these that'll go in. And again, it's got to be one of these numbers in red. So if I do 27 divided by 9, I found, okay, 9 times 3. So at this point, okay, the square root of 9 is 3. So again, now, I got to rewrite this because I forgot to leave myself room. We talked about yesterday, and again the day before, how there's this little number out here that we don't see. Sort of sometimes like we know that if I see a variable, its exponent's 1, my little root number is going to be 2. So what we're going to do here is we just do a little bit of long division. How many times does this little number divide into my exponent? 1 time. Okay, so 2 divided by 2 is 1, which tells me what my exponent will be on my x out here. If there happens to be a remainder when I do my division, but there's not this time, that would stay under here. It'd have to stay in radical jail. Same thing when I move to the next variable. I say, okay, so 6 divided by 2 is 3, which means my 3 goes out here. And when I go ahead and multiply that out, again, I don't have a remainder, so I don't have anything inside. That one's done, okay? And this is key, being able to break these down, because now what we're going to do today is we're going to go one step further. We're going to start adding these, and subtracting them, and doing things like that. So now we can actually move to a sheet that you have. So if we move this to the side, we're going to do a little bit of general work here. Okay, again, notice this is a note sheet. So when we get to the quiz on this, you'll be able to use this. So we're going to try to make a connection here between adding up things with variables and adding up things with square roots to find out there's really not that much difference. So for instance, if I have 3x and 2x, okay, that adds up to 5x. Well, I've known that. I've been doing that since pre-algebra. However, let's say now instead of x, it's square roots that I'm using. As long as they're the same, they're both the square root of 2, I can add them up just the same way. Okay? So we kind of treat the radical a little bit like it's a variable, okay? No big deal. And it works that way on anything. 4y and 3y. Okay, well I know that's 7y. I just add them up normally. 4 square root of 3 and 3 square root of 3. It's just like combining like terms, except now you're seeing a number with it instead of a variable. Works with subtraction the same way. Okay, I know there's a 1 here. 5x minus 1x would be 4x, because again, I'm just watching the signs of things. If I have 5 times the square root of 5, minus 1 times the square root of 5. That's 4 square root of 5. If they get bigger, the same thing keeps happening, but I've got to watch the signs that are in front. 8z minus 6z, if I just did this part, would be 2z, plus 4z would get me back up to 6. It's the same thing with the radicals. Okay, as long as they're the same, 8 minus 6 is 2, plus 4 more is 6, square root of 10. And you just start to see how much of a similarity there is as we move from piece to piece. They're all square roots of 7. 3 plus 5, watch the signs, is 8. Minus 2 is 6. But again, the whole key is, are they the same? One last little twist, and then we'll get to what we're actually going to jump into these with. I'm going to be brave here. I'm going to ask for assistance on this one. What's x times x? X squared. So the square root of 2 times the square root of 2. Now watch this. Is the square root of 2 squared? If you take the square root of something and the square of something, and that just means you're using that little 2, they're opposites of each other. And opposites, just like add and subtract, cancel. So here, the square root of 2 and the 2 cancel and just leave me with what's underneath. So the same thing happens whether I do it with a variable, y times y is y squared, or I do it with these. So you're like, okay, so this would be 2, and I've got square root of 5 and square root of 5 is squared. So every time I see squared and square root, they're opposites, right? And they wipe each other out. So this is just 2 times 5. So you start to notice this is really just like playing around with variables, except now I just get this kind of funky number working, okay? So here's how we're going to use this to our advantage when it comes time to work these out, okay? Again, keep this in a handy spot, because again, this is something you might be able to use when we're getting into the homework on this, because it's a little short today, but also some of the ones we're going to practice with. Okay? And we're not going to do every single one on this last part, but we're going to do some. Okay, again, notes here. So any ones that we don't do together, you don't have to complete those unless you want some extra practice and have me look them over, because it gives you some extra examples on the quiz. So, all right, here's how this works. First one's going to work exactly like we were doing the ones in the last sheet. Notice, always look at your square roots, okay, or your radicals first. If they're all the same, I can treat this like I would. I can treat this like I would any square root or any variable. So in this case, for instance, 5 plus 7 would be 12, and then that 12 minus the 6, because some of you, I think, sometimes getting all the things going at once kind of gets you going all over the place. Just do 2 at a time. So 5 plus 7 gets me to 12, and then minus the 6. Notice the square root's not changing, it's just the number in front. So it's just like combining like terms when we just have x's or anything else. But sometimes they may not all be the same. Sometimes, as I start to work my way down here a little bit, I start to notice, ooh, all those square roots aren't the same thing. So for instance here, okay, both of these have a square root of 7, but the other ones don't. So the only two I can put together in this case would be my 10 plus 4, which would give me 14 square root of 7. And then the others both have this square root of 11. So I can put those together. But remember to watch your signs. Here I got 5, but this is minus 6. So if I got $5, but then I spend 6, now I'm 1 in the hole, and since those square roots aren't the same, that's as far as I can go. It's sort of like having x and y, okay? Or it's two different types of variables. So only the ones that have the same number underneath the square root can be put together, okay? Like I said, just like combining like terms.
What if like one was like 11 and 4, you can break them down?
And we're getting to one of those. Because that will happen sometimes. So for instance here, it's just like what we did in example 2. I look and I say, okay, these both have a square root of 3, but I got to be careful because I have to look at the signs in front. So 4 and negative 6.
But the 3 and the 7, like the 7 both have 2 though.
Right, but when I'm looking at these to figure out what I can put together, I'm strictly looking at the number under here, because this is sort of like my variable term.
I know, but the 7's going to go too.
Yeah, well, we will put those together next, yes.
So it doesn't matter what you do first or not?
Nope, does not matter. So if you did the 7s first, that's absolutely all right. So here, if I've got 4 and a negative 6, that's a negative 2. But then like Maddie was saying, we still have the 7s that are alike. And they're both positive. So 3 and another 3 would be 6, but then that's as far as I can go because the 3 and the 7 are different. Now comes why we did that stuff at the beginning. Because Eric had just mentioned too, what happens if none of them are the same? Or what happens if I can break one down but they don't look the same at the start? This is when the challenge starts. Now I have to look at these and I go, well, 18, 32, and 72, they're all different. I can't do anything with these. But can I? I'm going to go part by part with these. And I'm going to try to break them down. And hopefully, as I attempt to break them down, I find a couple that end up being the same. So for right now, we're just looking at the square root. Forget about the 2. Think about our list that we had before. Let me see if I can get this all popped in here. There we go. So what's the largest number in my red radicals that goes into 18? 9 does. Okay, so I've got square root of 9. 9 times what gets me to 18? 2. So I'm going to break this radical down. Square root of 9. Okay, is perfect. It gets out of radical jail. That's 3. 2, not perfect. Has to stay in, still acting irrationally. That's right. Once I get this out of there, now that 2 that was sitting there comes into play. And the numbers that aren't in radical jail, I can times them. So 2 times 3 is 6. Okay? And I've got that one broken down. As you get more practice with breaking down, this will get easier and easier and easier. But here's one clue. Since this one had a square root of 2, the likelihood that the other ones are going to have one too is pretty good. So, okay, if I wasn't sure on this one, here's just a hint I would try. I have a feeling there's going to be a 2 in this one as well as there was one here. Try dividing the 2 into 32, and hopefully it's a red radical, and it is. 16. So I get here and I go, okay, let's see. Square root of 16 is 4. So 4 square root of 2. But there's a 2 hanging out on the outside of this one as well. So 2 times 4 is 8. And you're like, oh, so now they're going to look the same when I get to the end. Right, they're just not going to look that way at the very beginning. Now 72 doesn't have a number on the outside, so that's kind of nice. But again, I'm feeling the 2 is going to be here. Okay? if I divide the 2 into 72, I get 36. And again, having this chart readily available is not a bad thing. Okay? Square root of 36 is 6. It's just like having answers ready for me. Now it looks like the problem we were doing up at the top because all of my radicals are the same. So now I just say, okay, 6 plus 8 is 14, plus 6 is 20, square root of 2. Okay, now I'm done. Okay, I can't go to decimals on this because that's not going to get me to the same thing. It's something we're going to have to work with, but these are my key numbers. If you need the chart in front of you, keep it in front of you. Okay, you've got that help sheet too to help you out with these. But that's something we're going to kind of work with. Now, when we flip over to the back, same thing going on. Let me make sure our chart's still here. I want to take a look at one more up here, then I'm going to show you the last thing and we're going to be done. Not the same. Let's see if we can make them the same. All right, 54. Try to find the largest one of these that goes in. And again, if you're not sure, just start trying to divide some of them in. Use the calculator. Okay, if you try 54, you try 36, you're like, nope, that came up 1.5. Dang it. See? What's that? Okay, let's see if 9 works. 954 divided by 9 is 6. Okay. So, square root of 9 is 3. So again, I get that right off my chart here. And then if there's a number in front, and there is in this case the 4, I'll bring it down and then times those two numbers that aren't under the square root together. Now, there's that 6. So I have a pretty good feeling here that 6 is going to be one of my choices in the other one. 6 times what gets me to 24? 4. What a coincidence. It's in the list. So I've got the square root of 4, which is 2. Square root of 6. But there's a number in front. Multiply the numbers in front. 2 times 2 is 4. And hey, 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 like terms. 12 plus 4 is 16, and I am done with that. So again, in a lot of ways, it's similar to what we've been doing. It's just a breakdown like we've been doing the last couple of days, except now once I get done breaking them down, if they're the same, I can add them together. One last twist, and at least we're going to be able to move that out of the way for the moment here. What happens if instead of being asked to add or subtract, I'm multiplying them? Oh, geez. Okay. My little directions over here. Multiply the coefficients together. Multiply the numbers in front together first. So 3 times 2 is 6. Second, I'm going to multiply the radicals together. You can multiply the numbers. Just because I can't add or subtract doesn't mean I can't multiply. So 2 times 6 is 12. And if I can break down the radical, I need to. Okay? So this is where I bring my chart back up. And I say, okay, 12, yeah, 4 will go into 12. It's in my radical red list. So the square root of 4, notice I'm not doing anything with the 6 yet, just the radical. 2, because 4 breaks down. 3 is not radical in red. It's got to be left alone. And once you do that, now that 6 can come down, because it ain't in radical jail either. So it can get together with 2 here. and finish. No like terms on these. Just multiplying them together and breaking them down. Again, that's why I get you these kind of with the steps, so you can kind of see how it works, but also have some direction in case I'm not there to be able to help you right away. So one last one. Want to do 9 here, and then I'm going to do a couple homework problems with you and then set you on your own here for a bit. All right. Multiply the coefficients. 2 times 7 is 14. Multiply the radicals. 6 times 3 is 18. And I'm willing to bet more times than not these are going to be able to be broken down. What off our list goes into 18? Okay, 9 and 2. 9 from our radical reds and 2 just because. So the square root of 9, again from our list, is 3. 2 is not in the list, so it's got to stay in radical jail. Unfortunate for it, but hey, it acts irrationally. That's just the way it happens. And then 14 times 3 is 42. Square root of 2, because I can multiply the numbers in front together. This is just one of those things that you've got to play with it until you're going to get used to it. I know some of you, just the idea of seeing this many numbers going along down with steps really is like, you're a little hesitant. But again, unless you kind of mess with it, it's not going to get a whole lot easier. So when we get to the actual worksheet, okay, and we're actually going to be saving on the multiplying until tomorrow on this worksheet part. When we get over to here, okay, and this is the actual homework, we have finally made it. Some of the problems up here towards the top are going to be like we had at the start. Look to see if your radicals are the same, like let's say here on number 3, they're all square root of 5. I can just look at the numbers in front and combine terms. 6 minus 2, if I do these a couple at a time, would be 4 square root of 5, because I do have to watch the signs, even though it's combining like terms. Doesn't mean it gets bigger every time. And then 4 plus 8 is 12. Square root of 5. I'm done. Nothing to break down. If I looked at the 5 and tried to break it down, I'm going to find out I can't. Okay, so I'm just combining like terms up there. But as I move a little further down the sheet, like let's say to 8, well, those aren't the same. What am I supposed to do? These are the ones that'll end up breaking down, where I need to bust out whichever list I want to use. Which one of those numbers, which radical red goes into 28? And yes, one of them does. 4 does, okay? 4 goes into 28 7 times.
You do 63 divided by 7.
What's that?
You do 63 divided by 7.
That's where we're heading next, yes, because the square root of 4 is 2. Square root of 7, and good mention there. Well, hey, since the 7 is the one that didn't break down, really likely that's going to be one of my numbers over here. So then I don't even really have to think as much. I'm like, ooh, I'll just do 63 divided by 7 and see what that equals. Hey, it equals 9. Hey, that's a radical red. Awesome, because now I can break this down. So the square root of 9 is 3. Square root of 7. And amazing, now they're the same, my radicals. So just add the numbers in front. 2 plus 3 would be 5. Square root of 7, and I'm done. So your task is between using the examples that we did on the sheet and the examples we've done here at the start is to knock this out, and we'll be doing this again tomorrow just to kind of see, and we're going to add some more multiplication problems in, but give yourself a start and just play with this some because it'll make it a lot easier.